अब कंडक्टिविटी एंड रेजिस्टिविटी में हम जुड़ेंगे तो हम ये देख रहे हैं इट मस्ट इज द कंपोनेंट ऑफ फॉर दैट in a metallic conductor at a constant temperature the current density J is linear proportional to the electric field. J is equal to sigma into E. J is equal to sigma into E. E is the electric field, sigma is constant. This is the conductivity inversely proportional by resistivity. तो आप कह सकते हो कंडक्टिविटी 1 अपॉन resistivity. This is the sigma is constant. Sigma is constant. This is the charge particle is movement by the any direction. Consider first a particular piece of current carrying a material like the wire. If at any instant current is directed toward an insulated boundary of the conductor, it will produce steadily increase added field due to the pulling up of the charge at the boundary. Therefore, for the steady flow of for which there is no source or sink of the current, they just must be parallel to the conductor boundaries. If we consider two surfaces S1 and S2, where the perpendicular to J, each found by curve lying in the conductor boundary, the current. This is the flow of the electric current in given area. I is equal to ये J into ds, so with the value of S1 and flow of the second current is the given of area S2J into ds. This is the J is the dependent of the electric current. So we define of these current must be same through any surface across the wire. Current behave like the electric flux. We can draw lines of the flow of the wire parallel to J that do not feed, begin or end any conductor. Since E and J are in the same in direction, we can write this is the factor of E is equal to rho into J, or this is the define of these. Rho is equal to 1 upon sigma is the value of E is equal to 1 upon sigma into J. So this is the value of J is equal to sigma into E. This is the density of conductivity of the electric current. J is equal to value of A. So we define of the J is equal to conductivity 1 upon A into sigma into E. There are many conductive resistivity is the constant independent of the E. This theory was rho is constant for a metallic conductor at the temperature. Now is a Ohm's law. A material being Ohm's law is called the ohmic conductor or a linear conductor. Only metals and metal alloy are under this head, this Ohm's law. Like Boyle's law, describe a special property of certain material and not a generally property of all matter. In non-isotropic conductor, the current many may flow more easily in the some direction than in other. In this case, we written as is the value of Jx. This is the value Jx is equal to sigma 1 into Ex and J by is equal to sigma into E by and Jz is equal to sigma into E into Z. This is the two components of the value of the every time is change of the conductivity. We define is the J x is equal to sigma 1 Ex J by is equal to sigma 2 into E by, and J Z is equal to sigma 3 into Ez. This is the current density every time change of these. So with the sigma values changing, so we can define the resistivity of the metallic conductor. Increase with increase in temperature. It is practically independent of the temperature alloy. Magnin, the general expression of the resistivity of a pure metal is the temperature C. तो रेस्टिविटी इज इक्वल टू आपका वैल्यू हो जाएगा ये T इज इक्वल टू सिग्मा 1 प्लस अल्फा अल्फा टी और प्लस बीटा टी का स्क्वायर गामा टी की क्यू अप टू डॉट डॉट. तो पी टी इज इक्वल टू लीनियर एक्सपेंशन सो बी डिफाइन इज द रो इज इक्वल टू रेस्टिविटी 1 प्लस अल्फा इंटू टी. तो रो इज इक्वल टू रो नॉट प्लस रो अल्फा इंटू टी. This is the temperature of the rho upon rho naught is equal to alpha into T. This is the temperature is defined as value of alpha is constant rho T minus K rho 0 upon rho 0 into T के साथ. This is the alpha is the linear coefficient of the material. Is defined as the fractional increase in resistivity per degree inverse in temperature. The plotting the graph of the three graph resistivity and temperature. Resistivity in and temperature. Three graph plotting of the condition. Resistivity into time, resistivity into time or resistivity into time. Metal, semiconductor or superconductor. This is the value of metal in producing the graph in metal and semiconductor. Semiconductor of the plotting the graph every time it change, and superconductor is the plotting the graph. This is the value of define variation of the resistivity with temperature. Variation of the resistivity of with temperature. Metal, alloy, semiconductor and insulator. Metals are silver, copper, aluminum, gold, iron and tungsten, and alloys the brass, constitution, manganese, nichrome, semiconductor carbon, germanium, silicon, and insulator glass, mica, wood, amber, sulfur and quartz. With the resistivity of the superconductor, as alloy the compound decrease, the temperature is decrease. It is firstly gradually like that of a metal and suddenly plunges to zero at a certain temperature. Now is a critical temperature. These resistivity of the various substances at 20 centigrade. The large difference in the resistivities of conductor, semiconductor and insulator is due to a large difference in the carriers concentration rather than to a difference in the mobility of the charge carrier.